Momentum and impulse. While students are entering the classroom, show this slide on screen. When the bell rings, click this slide. Remind students that they have 5 minutes to complete this bell ringer. While the students are doing the bell ringer, check their attendance and distribute the classwork sheets. Let's get started. At the end of the 5-minute period, discuss this bell ringer with your students. Lesson 5.1 Momentum and Impulse. By the end of the period with at least 80% mastery, students will be able to define momentum and impulse, solve problems involving momentum and impulse. Impulse and momentum play important roles in sports. In bowling, in baseball, in tennis, in soccer, in karate, and in football, and in golf. Let's start with everyday language. What do you say when a sports team is on a roll? They may not have the lead, but they may have momentum. A team that has momentum is hard to stop. An object with a lot of momentum is also hard to stop. What is momentum? All objects have mass. So, if an object is moving, it has momentum. It has its mass in motion. In terms of an equation, momentum equals mass times velocity. We give a small letter p a symbol for momentum, so p equals m times b, where p is momentum in kilogram meters per second, m is the mass in kilograms, and v is the velocity in meters per second. Momentum is a vector quantity. That means it has both magnitude and direction. The direction of momentum is the same as the direction of the velocity. A moving object can have large momentum if it has a large mass, high speed, or both. A moving truck has more momentum than a car moving at the same speed because the truck has more mass. A fast car can have more momentum than a slow truck. But a truck at rest has no momentum at all. Let's look at the impulse now. How hard is it to stop a moving object? To stop an object, we have to apply a force over a period of time, and this is called impulse. So impulse is equal to the product of the force and the time elapsed. Capital letter I is equal to F times T, where F is the force in newtons, T is the time elapsed, and I is the impulse in Newton second. Applications of impulse. Apply a force for a long time. This is an example of a follow-through on a golf swing, bat swing, tennis, and also pushing a car. Apply a force for a short time. This can be seen in boxing or experienced in boxing, also in karate. Now let's study the impulse momentum theorem. Using Newton's second law, F equals mass times acceleration, and since acceleration is change in velocity over time, we get, after replacing A with A equals delta V over T, we get F equals M times delta V over T. Multiply both sides by T, we get F times T equals M times delta V. The quantity Ft is called the impulse, and the quantity M times delta V equals change in momentum. So this is now the impulse momentum theorem. It says the impulse is equal to the change in momentum. for I equals delta P. Since I is Ft and delta P is m times delta V, simplifying, and we also learned last time that delta V is final velocity minus initial velocity, simplifying if T equals m times Bf minus m times Vi. Let's look at this situation. Would you rather be in head-on collision with an identical car traveling at the same speed as you or a brick wall? Assume in both situations you come to a complete stop. Take your guess. The answer is, it does not matter. If you look at the equation, if T equals m times delta V, in both situations, T, m, and delta V are the same. The time it takes you to stop depends on your car. M is the mass of your car, and delta V depends on how fast you were initially traveling. To summarize, we learned the following formulas. 1. Momentum P equals m times V. If you want to solve for m is P over V. Or if you want to solve for V equals P over m. Second formula is the impulse, I equals F times T. If you want to solve for F, we have I over T, and solving for T, this is I over F. Third formula is the impulse momentum theorem. It says the impulse is equal to the change in momentum, where P is momentum in kilogram meters per second, m is the mass in kilograms, v is the velocity in meters per second, I is the impulse in newton second, F is the force in newtons, T is the time in seconds, and delta P is the change in momentum, kilogram meters per second. Let's do some examples now. Determine the momentum of a 75 kilogram halfback moving eastward at 10 meters per second. Solution from P equals mv. M is 75 and V is 10. Therefore, the answer is 750 kilograms meters per second. And since this is a vector quantity, we need also the direction, which is eastward. Number 2. What is the mass of a bowling ball rolling at 3.5 meters per second, which has a momentum of 20 kilogram meters per second? So we are required to find the mass. So mass equals P over V. Substituting, we get the mass is 5.7 kilograms. How fast will a 60 kilogram carton slide on an icy surface if its momentum is 300 kilogram meters per second? So we are required to find the velocity. V is P over M. Substituting the values and simplifying, we have V equals 5 meters per second. Number 4. A golf ball exerts a uniform force of 22 newtons on a golf ball for a period of 0.22 seconds. Calculate the impulse. So I equals F times T. Substituting and simplifying, it is 5.5 newtons second. Number 5. A 0.10 kilogram model rocket's engine is designed to deliver an impulse of 6 newtons second. If the rocket engine burns for 0.75 seconds, what is the average force does the engine produce? So we are required to find the force. force equals I over T. It is equal to 6 divided by 0.75, which is equal to 8 newtons. Number 6, a karate expert chopped through cement blocks with a bare hand. If he exerted a force of 1025 newtons and the impulse was 345 newton seconds, how long was his hand in contact with the cement block? We are writing time. So time is I over F, substituting the values and simplifying. This is 0.34. Number 7. A 0.5 kilogram object is at rest. A 3 Newton force to the right acts on the object during a time interval of 1.5 seconds. Letter A, find the impulse, and letter B, find the change in momentum. So solving for the impulse in letter A, I equals F times T, is 3 times 1.5 newtons, 1.5 seconds. So the answer is 4.5 newton seconds. Letter B, find the change in momentum. So solving delta P equals I by the impulse momentum theorem, this is also the same as 4.5 kilogram meters per second. Since we are required to find the change of momentum, its unit should be in kilogram meters per second. If there are no more questions, then let the students complete the classwork until the end of the period. Have a nice day.